testing, and implementation to address water quality standards within the Everglades agricultural area. My name is Gary Priest, and I'm with the South Florida Water Management District, and I have the pleasure of introducing the presenters this morning. First, we have Thomas Davison, also with the South Florida Water Management District. Thomas will provide some background information, historical perspective, and bring us to recent activities regarding the master permit renewal. We'll also hear from Dr. Samira Darub with the University of Florida. Dr. Darub will provide deeper insight into the EAA EPD research permits proposed scope of work. We'll then take comments regarding the proposed permit renewal. And then finally, Thomas will discuss the timeline for the next steps for the permit renewal. But before I turn it over to Thomas, we do have a few housekeeping items to discuss. This meeting is being live streamed and recorded. Public comment will be taken at the end of all the presentations. We'll take public comment first from those in the room, and then from those on Zoom. We do ask that you please keep your comments to 3 minutes or less. When commenting, please make sure your microphone is on, that you state your name for the record, and that you speak directly into the microphone. Comments can be captured, and so those on Zoom can hear you. And with that, I turn it over to Thomas Davison.
All right. Good morning, everybody. So, a little bit of background regarding the Master Research Permit. So, the Everglades Forever Act mandated that Rule 40E63 be amended to implement a comprehensive program of research, testing, and implementation of BMPs to address water quality standards within the Everglades Agricultural Area, the EAA, and the Everglades Protection Area. So the Everglades Forever Act specifically states that EAA landowners, through the EAA Environmental Protection District or otherwise, shall sponsor a program of BMP research with qualified experts to identify appropriate BMPs. Consistent with the Water Quality Monitoring Program, BMPs will be field tested in a sufficient number of representative sites in the EAA to reflect soil and crop types and other factors that influence BMP design and effectiveness. And then the district shall conduct research in cooperation with EAA landowners to identify water quality parameters that are not being significantly improved either by the stormwater treatment areas, STAs, or the BMPs, and to identify further BMP strategies needed to address these parameters. So in response to what the Everglades Forever Act mandated, 40E63 Part 3 written to establish a schedule on BMP research, testing, and implementation to identify water quality parameters that are not being significantly improved by STAs and the current level of BMPs being widely implemented throughout the EAA, and to identify strategies to address such parameters. It also states that the research program prescribed by this chapter shall include field testing of BMP in sufficient number of representative sites in the EAA which reflect soil and crop types within the EAA, as well as other factors that affect BMP effectiveness and design. And it also provides for this rule to be reviewed at a minimum of once every 5 years and to be amended if necessary. Chapter 40E63 requires that the scope of work for research to be approved if it meets these specific conditions for issuance. Number one, the scope must provide verification of BMP effectiveness at 10 farms or at other locations in sufficient number to reflect soil and crop types and other factors that influence BMP design and effectiveness. Number two, it shall include development, testing, and implementation of BMPs for reduction of particulate phosphorus. Number three, includes monitoring for specific conductance and development, testing, and implementation of BMPs to address specific conductance. Number four, monitoring for atropine and ametrin in accordance with FDEP operating permit. Number 5, it must include an education and prevention program for misapplication of pesticides. And number 6, the scope of work must be initiated. The research must be initiated within 6 months of the scope being approved. An overview of the history of the master research permit. And so in 1997, the first scope of work from 97 to 2001, BMP effectiveness studies at 10 representative farms. From 2001 to 2005, BMP effectiveness studies with focus on conductants and particular phosphorus BMPs at 3 farms. From 2005 to 2010, statistical analysis of research permit data and comprehensive particulate phosphorus BMP demonstration at UF IFAS. From 2010 to 2015, improved management of floating aquatic vegetation, FAV, at 8 farms. 2015 to 2020 was continued research of improved management of FAV. 2020 to 2025, the current scope of work, implementation and verification of BMPs to reduce EAA farm phosphorus loads, evaluation of performances of EAA farm basins with similar BMPs, and the proposed scope for 2025 to 2030, continued research on the evaluation of performance differences at EAA farm basins with similar BMPs. And so here's an overview of the chronology for the review of the application for the renewed scope. So on April 10th this year, the scope of work was submitted for the 2025 to 2030 period. The application number is 250-410-1. On May 6, 2025, South Florida Water Management District sent a request for additional information letter asking for clarification on specific items. On June 5th, 2025, the EAA EPD sent a response to that letter clarifying the items that were asked about, and a new scope, a revised scope, was provided. And then on July 9th, 2025, the 5th annual report for the current scope of work, the 2020 to 2025 period, that annual report was submitted. And then here we are today at the public workshop to review the proposed scope of work. And so an overview of what is being proposed. So the proposed scope to determine differences in performance in select farms in the EAA basins by evaluating the impact of soil chemistry and historical land use on phosphorus concentration and loads on these farms. And then to integrate additional statistical tools to evaluate the influence of soil properties, historical and current land use, and environmental conditions on water quality in select farms in the EAA. And then BMP education and extension, using the information from this research to determine what BMPs work most effectively on farms in the EAA with similar soil, crop, and management conditions. So to go into depth on the proposed scope will be Dr. Samira Daroub.
Thank you, Thomas. Good morning, everybody. It is my pleasure to present this scope of work, but I'm going to start first talking about the research we have been conducting. As Thomas mentioned, this is the master scope of work renewal for 2025 to 2030, entitled Evaluation of Performance Differences in EA Farms with Similar BMPs. So I'll talk a little bit, again, very briefly, since Thomas covered this, about the works of District Master Scope of Work Permit Renewal. I will review the progress of the current Master Scope of Work, talk about the objectives, the methodology, go over some limited results. If anybody wants the annual report, let us know. And I talk about the variability in soil and water quality and the impact of COVID-19 on the start of this project. And then I'll talk in more details about the proposed scope of work for the next 5 years, the objectives, the methodology, and the timeline. So as Thomas mentioned, we're here for the renewal of the master permit scope of work. Usually it is 5-year duration, of course. The scope of work will expire in September 15, 2025. So let me start first by talking about the progress of the current master scope of work and talk a little bit about phosphorus chemistry in the soil. As some of you might know, the EAA is unique in its organic soils. The phosphorus cycle in these soils is quite complex because it involves both an organic component and inorganic component. So the organic phosphorus mineralizes, releases phosphorus in soil solution, which can be taken up by the plant. It can stay in the soil solution unless it is sorbed by certain minerals in the soil or precipitated. The soils will have some mineral content like iron and aluminum oxides and some calcium carbonate as well as some calcium minerals. Our soils are getting shallower because of the organic matter oxidation, and so this mineral content and the properties of these soils are different. So phosphorus can be sorbed on, as I mentioned, secondary minerals like iron minerals, aluminum minerals, and it also can precipitate in the soil. But organic phosphorus, organic chemistry or soils, in organic soils, the phosphorus chemistry is quite different from mineral soils because of the high organic matter content. So in the EAA, soils are classified depending on the depth of the O horizon, which is the organic horizon. It's a very rich organic matter horizon, usually more than 60% or 70% organic matter, depending on the location. So this is a map, a recent map of the EAA. This is from 1988. You'll see the different soil series. Soil series classification is regarding mainly the depth of the O horizon, but also it can include what is the C horizon. Most of the time, the C horizon is calcium carbonate, but it can include a lot of sand material too. So closer to the lake, we have the Torrey series, which is a little bit more inorganic, 35% mineral material. It is classified as an organic soil, but because of the mineral material, it is less subject to subsidence, and mostly phosphorus would be stored more strongly on these soils. As we move south of the lake, the soils become shallower, and the depth of the O horizon changes from 129 centimeters to as low as 20 to 60 centimeters. So shallower soils, again, tend to have more inorganic components, except for the Torrey series, which has a lot of mineral materials. You know, the theory they would have more iron oxides, aluminum oxides, and calcium carbonate. That will increase phosphorus sorption capacity. So the justification of the research when we started this, talking about this before 2020, is we observe from our data and from the district data, there is a lot of farms that implement similar BMPs. The permit is the same, the management practices are the same, the soils seem to be the same on the surface, but we still see differences in farm discharge, whether it's concentrations or phosphorus loads. And our hypothesis was maybe these differences are related to historical cropping practices. It may be related to the changing soil properties in the soil, as we have talked about, that the mineral content, the phosphorus saturations related again to the depth as well as the cropping histories make an impact on phosphorus concentrations and phosphorus load. And really conducting this research will give us quite a bit of knowledge why this happens and what can we do about it eventually. So understanding the system will be very important. So our hypothesis was that the phosphorus in drainage water is impacted by the cropping practices historically. Deeper soils might have capacity to mineralize more phosphorus, and soils with low phosphorus sorption capacity. So soils have less mineral content, whether it's iron, aluminum, or calcium minerals, which are those minerals that sorb phosphorus in these soils. So our main objectives in the original scope of work that we just going over some of the results is to determine the difference in performance in select farms in the EAA basin, evaluating the impact of soil chemistry, again, as we've mentioned, and historical land use on this phosphorus and water quality. And then we'll continue with the BMP education and extension activities, and I'll talk a little bit more later on. So the selection criteria, we started this again before the scope of work was approved, so it's a long process to select the farms. We wanted farm pairs to compare that will have, the pair would have the same operator, the same BMP plan or very similar plan. We wanted also to see have soils types that are very similar and cropping management practices. So this is the farm selection criteria. And then we wanted them to have historical phosphorus loads or concentrations because we want to see the differences and why these differences are there, and also cover the different geographical basins. So we selected 3 farm pairs, one in the S5A, S6, and S7 basin. These are the basin ITs, 1801, 1803, that's farm pair 1, 2801, 4801, farm pair 2, and 6107, 61112, farm pair 3. So I'll probably talk about them as farm pair 1, 2, and 3, S5A, S6, and S7. Farm pairs 1 and 3 would have a lot of, the cropping practice for the most part is mostly sugarcane, but there's a lot of rotations of sweet corn and vegetables, while farm 2 is mostly a vegetable production farm with rotations of sugarcane and other crops, including rice. We have complete data of the current cropping practices. We observe that in the field as we go. Also looking at the nutrient, the BMP permits and what practices they have. Again, very similar in the farm pairs in terms of the nutrient control practices, the points, the sediment controls, and phosphorus and water management. So a lot of these are very similar in the farm pairs, and that's why we chose them. And again, these are the crops that I've mentioned, mostly sugarcane in farms pair 1 and 3, and vegetables in farm pair 2. And they have different areas, acres. All right. So this is when we started looking and selected these farms. We looked at 10 years of historical data. This is farm permit data. This is total phosphorus. I don't see without my glasses. Okay, total phosphorus, milligrams per liter, and the differences between the farm pairs. And this is adjusted area unit load. Again, this is permit data from the South Florida Water Management District. We use the Kolmogorov-Smirnov test, evaluates the differences in either the mean and the median, and the variance distribution as well, and determines if there are differences in either the phosphorus concentrations, the TP, as well as the adjusted unit area load. So these farm pairs were selected because they either had differences in unit area load, as you see farm pair, or both concentrations and unit area loads, or just concentrations. We started this project in 2020, and we did a lot of extensive soil sampling. And according to the master scope of work, we sampled at least 15% of, so at least 5 plots. In some of these farms, like 2801, all the farm, basically, because it only had 5 plots was sampled. In larger farms, like the first farm pair, we sampled 22 and 34 plots. So, but minimum of 15% were sampled. We did initial complete characterization measurements at 2 depths, 0 to 6 and 6 to 12 inches. This is the first year characterization of the data. We looked at pH, organic carbon, organic matter content, total phosphorus, total nitrogen, again, the mineral content, iron and aluminum, calcium, actually magnesium also, and calcium carbonate, and we measured soil depth. In addition, we did water extractable PW and milk extractable PM3. Water extractable, these 2 tests are done for testing available phosphorus in the soils, in organic soils in the water extractable measures available phosphorus on a short term, like for vegetable production, while MALIC 3 measures available phosphorus on the longer term, and it's used for sugarcane production. We did this for year 1, but we also do it every single year. So we go sample the soils and do these available phosphorus measurements. And to compare the soil parameters at this point, we use a non-parametric Wilkinson ranked sum test to do the statistical analysis if there are differences in soil testing between farm pairs. So I'm going to present very limited data because I want to focus on the proposed scope of work. This is soil properties, difference in the median value of both water extractable, PW, and MALIC 3, PM3. The units is in milligrams per kilogram. Farm pairs 1, 2, 3. And you will see that for water extractable P, there is differences between the farm pairs in pairs 1 and 3, while in milk extractable farms pairs and 2 and 3 are quite different. And these were the sample sizes that we have. So definitely differences in available phosphorus in these farm pairs, again, although they have very similar soils, as well as management practices and cropping practices. We also look at the phosphorus saturation ratio in these soils. Phosphorus saturation is the amount of available phosphorus in the soil divided by the mineral content, mainly extractable aluminum and calcium content. So we calculated the phosphorus saturation ratio. Also calculated the soil phosphorus storage capacity, but I'm not presenting on that. But this is an example from wetland soils. What they see, the threshold is usually at 10%. And you can see, when you have higher than 10%, definitely there is more saturation, and it may impact water quality depending on the transport, of course. So in our soils, against farms pair 1, 2, and 3, in farms pair 1 and 3, these soils they don't have a saturation higher than 0.1. Actually, they fall below the line. There are differences between farm pair 3 and farm pair 3. No differences in farm pair 2, but definitely the phosphorus saturation is higher. So the good news is a lot of our fall below the 0.1 that we are investigating, and some soils that had historically vegetable production will fall 0.1 because of higher fertilizer rates. Another parameter we looked at is phosphorus sorption capacity. Remember, the phosphorus sorption capacity depends on the mineral content, whether it's iron, aluminum, or calcium. It definitely, this is S-max, again, farm pairs 1, 2, and 3. S-max is the maximum sorption capacity of these soils. It varied between each farm pair, whether farm pair 1, 2, and 3, there were differences in the phosphorus sorption capacity, and highly correlated with the amount of aluminum and iron, and inversely correlated with the organic matter content. So the next part of this research, of course, is to focus on water quality, and we have extensive implementation on all of these 6 farms with data loggers, canal level sensors, RPM sensors for the pump. We have auto samplers with solar panels and refrigerators with solar panels, rain gauges. Everything is monitored remotely. Water analysis, we couldn't start it in year 1 because of COVID limitation. We had a lot of delays in getting the equipment during COVID. We started water analysis with the second year during water year 2022, I believe. And what we do is during drainage events, we do composite samples daily. A number of measurements is done on water quality, including pH, total phosphorus. We do speciation also. So we measure total dissolved phosphorus. We calculate, and we measure soluble reactive P. So total phosphorus is measured, total dissolved phosphorus, soluble reactive P. This is organic. Of course, we calculate particulate phosphorus, which is a measure of the phosphorus that is associated with soils and sediments. And we measure also dissolved organic phosphorus. It's calculated. We also measure total suspended solids in these samples. For the analysis that we did at this point, we did statistical analysis, just comparing the farm pairs using non-parametric 2 methods, non-parametric Kolmogorov-Smirnov test and the rank sum test. So I want to start first looking at, again, 4 years of data, year 2022, 2023, 2024, and 2025. This is farm pair 1, 2, and 3, as we've been talking about. Phosphorus in the water, this is not flow weighted, it's just phosphorus with speciation, and the percentage of the species. Dissolved organic P is in the blue, particulate phosphorus is in the red, and then soluble reactive P is in the green. As you can see, there are variations between the water years. There are variations between the farm pairs also. Farm pair 2 has a lot of soluble reactive phosphorus. In it, contrast, farm pair 1 has a lot of particulate phosphorus. Dissolved organic P seems to be also a significant portion of what we see at this point, especially in waters year 2, 3, and 4. And we also, of course, calculate drainage or measure drainage, calculate unit area load. This is not just unit area load adjusted per area. This is total drainage in these farms over the 4 years. And again, you'll see differences between the farm pairs, but also between each year. So there's a lot of variability depending on the weather. And of course, when we calculate the unit area load per acre, you will see differences depending on the size of the farm. If the farm has low area and they pump it more. Okay. So we put everything together to make sure we still have that differences between the farm pairs. This is a graph that shows the flow weighted phosphorus, the unit area drainage, and in the middle, the unit area load. Farm pairs 1, 2, and 3. We did 2 tests to see if this relationship still holds in terms of the differences in either concentrations or unit area load or drainage. And definitely it holds. For example, for the farm pair 1, a lot of differences in flow weighted TP as well as drainage. The statistical analysis that we've used, we've done 2 of them. Farm pairs 2, you'll see differences in unit area load and drainage. And in the third farm, there's differences in all of the parameters. So one of the things that you may have noticed while I was talking about the water analysis as well as the soil analysis, there's a lot of variability between the farm pairs, but there's also a lot of variability within the water years. And we wanted to do point is really investigate further to eliminate that weather factor and incorporate more data points, as well as use, as Thomas mentioned, additional statistical tools that will allow us to delve into a lot of environmental factors as well as the soil properties in a very holistic manner. So this is proposed master permit scope of work. And the justification for it is we had a lot of delayed start due to COVID, so we did not get many samples in first water year, so we only have 4 complete waters of data. As I mentioned, the preliminary analysis reveals there are significant variability in soil and water between the years, between the farm pairs. So highlighting the necessity to extend the data collection to make sure we have a robust statistical evaluations that will give us, hopefully, definite answers. And in addition, these statistical tools that we're going to use really require comprehensive long-term data sets. 4 years of water quality data is not enough to be able to assess these relationships among the geo-environmental factors, the soil chemistry in relation to water quality and phosphorus load. And of course, time is needed for all of this data evaluation, calibration, and validation of statistical models. So in addition to the 2 objectives that we have in the current scope of work, we added a second objective to integrate additional statistical tools to evaluate the influence of soil properties, historical and current land use, and environmental conditions on water quality, again, in a very holistic, comprehensive manner. So we're employing a whole systems approach through advanced statistical methods to evaluate drainage water phosphorus concentrations and loads in these selected studied farm in the EAA. The data analysis, although we will have regular statistics like linear regressions and multivariate regression, but it will focus mostly in learning, predictive, and explainable AI models. We're gonna have also additional data sets, collected data, characterization details, the geo-environmental factors, annual characterization of the soil chemical and physical factors. And 3, the bulk of the data is to link this geo-environmental, soil chemical, and physical factors into statistical models to explain what is happening in these farms. So this is the additional data that is needed. We're beginning collecting. As I mentioned, the characterization of the soil parameters happen in year 1. On an annual basis, we do water extractable and malic extractable, but now we're going to characterize the soil parameters in details every single year. We're also going to collect grab samples during non-pumping events, which we have not done in this project. And this is to get us a baseline value for these farms. We're going to also do this phosphorus speciations of these grab samples. We're going to collect data on historical cropping rotations going back maybe 20, 30, 40 years when available. In addition, we're going to collect remote sensing spectral data for land and cover vegetation characterization, because that will give us also really a knowledge and maybe about what was the land vegetation in 20, 30, 40 years from satellite data. We're going to do scanning of soils and vegetation with spectroscopy, visible near-infrared spectroscopy. And we're going to also download a lot of soil characterization data sets. We're doing a lot of characterization, but there's, from the United States, USDA and RCS, there's new published high resolution, 100-meter resolution from soils that we're going to use in the modeling also. So the first step is to characterize the geo-environmental factors affecting phosphorus load. As I mentioned, we're going to download soil landscapes from the United States. It's available for the whole US. Of course, we're going to do it for the EAA from NRCS data. It's called SOLIS 100-meter resolution. We're going to try to get a lot of the historical cropping rotations through BMP permits, farmers interview as available if they have records. But we're also going to depend on data from Landsat or Sentinel-2 the past 10 years. We may go further depending on the availability of data to characterize land cover and vegetation. Landsat has about 40 years space-time spectrum. And then from this data, a lot of vegetation indices can be derived, like normalized difference vegetation index, to see the difference in the vegetation and the changes along these 40 years. There's other indices like enhanced vegetation index and the normalized difference tillage index if tillage happening too. Additional data to be collected from for crop, vegetation. We can, as I mentioned, use remote sensing images, but we're going to do also ground truth data, the field and see what's going on and try to compare that, of course. There's also available land use geodata. So a lot of these will be explored to be able to download this data. Climate data is important because soil moisture and the need for drainage will be important to have, be important for the models also. And this is available. Okay, so the second task in this proposed scope of work would be to characterize the soil chemical factors, as I said, on an annual basis. And we've done this in the past: pH, organic carbon, organic matter, total phosphorus, P content, mineral content, iron, aluminum, calcium, and magnesium, and as well as calcium carbonate. I always forget something. And we're going to scan these soil spectral analysis and build a spectral library. So this will be nice to be able to validate these models, what the spectral analysis is giving us compared to the soil characteristics that we have on an annual basis. So lastly, the bulk of this work will be to link all of this data together into models to explain the water, the impact of all these different factors. In the past, we've always seen that drainage components really kind of overwhelm the phosphorus loads and explain how to explain phosphorus load. But we really wanted to see what is the impact of soil chemistry, the impact of soil crop rotation, and all this data sets will allow us to train and validate this explainable AI models to be able to predict the phosphorus load from all these different data. So machine learning nowadays and deep learning models are extraordinary in what we can accomplish. I don't want to overpromise, but a lot of AI methods and models will be tested to see the best performing models to predict these phosphorus load. And of course, we'll assess the model performance. All right, so my co-PI on this project will be Dr. Sabina Grunwald, because she is a data analysis expert. She does a lot of these machine learning predictive models. She does quite a bit on digital soil mapping, remote sensing, and geospatial technologies, as artificial intelligence, as I mentioned. And she's with the University of Florida also. So this is the proposed scope of work. I just want to mention a few more things about what we do in terms of the last objective, which is BMP training. We have in-person BMP training twice yearly. This last water year, we had about 230 participants, really excellent participation, quite a bit of people presenting, including scientists from the University of Florida, the Extension Service, as well as growers, to be able to educate the EAA community. In addition, for those folks that cannot make it in person, since COVID, we had online BMP training. We update single year. Last year, I had 76 that successfully completed the online. It is always available, finish at own pace till December 24, because I don't want any emails on December 25. Yes, which I've had in the past. But it's 6 modules that covers the BMP program, so all aspects of BMPs, and we have a lot of people from across Florida taking this class, and it's also available in English and Spanish. Finally, this is the updated timeline. We have added the new objective to utilize the tools for statistical analysis. We've added all this data on historical crop rotation, acquiring the remote sensing data, geospatial scans, ground truth data, and the statistical models. So this is the 5-year timeline. Annual reports are always in July and presented at landowners here in the Everglades agricultural area at the University of Florida IFAS location. And a final report will be submitted on this project in September 2030. So thank you all for your attention. And I thank my lab for their hard work. And I give it back to Thomas.
Thank you very much, Dr. Darub. Excellent. So for everyone's information, e-permitting is still available for works of the district permits, and all information for the review of the master research permit is available on e-permitting under application number 250-10-1 or permit number 50-00001-E. Please note that after September 8th, 2025, Reg Permitting Portal will be available for searching records that will be replacing e-permitting. All right, so now we are entering the public comment period. All members of the public present at this meeting or present on Zoom are welcome to make public comment. Out of respect for everyone's time, please keep your comments to 3 minutes or less. There will be a timer on the screen counting down from minutes. Please keep in mind that this is a public meeting being live streamed online, and there will be a recording posted online after the meeting, which we'll talk about. Also, any member of the public may give public comments for 30 days after this meeting. So this is not the only opportunity to give public comment. We'll talk about that here in a second as well. So we're going to start with any public comments from people here in the room, and then we'll get to the folks on Zoom. For those here in person, if you wish to make public comment, there is a microphone stand here in the front of the room. So please make your way to the microphone stand if you have a comment, or raise your hand if you're unable to make your way to the microphone stand. When giving a public comment, please state your first and last name for the record, and make sure you speak directly into the microphone so your comments can be captured and that those on Zoom can hear you. And then remember to keep your comments to 3 minutes. Any public comment from the folks here in the room? All right. So we'll proceed to public comments via Zoom. So for anyone wishing to make a public comment on Zoom, please use the raise hand feature. If you called into the meeting using your telephone, pressing *9 on your keypad will raise your hand. and then we will call your name. And when we call your name, please unmute yourself using the unmute feature. You can press *6 on your keypad to unmute yourself and to remute yourself when you're finished giving your comment. Make sure that when you begin giving your comment, please state your first and last name for the record and speak clearly so that everybody can hear you. And please remember to keep your comments to 3 minutes. All right, so the first public comment, I see a hand raised by Mr. Mark Perry.
Yes, good afternoon. Can you hear me okay?
Yes, sir, we can hear you.
Thank you. Mark Perry, Florida Oceanographic. We've been kind of following a lot of the, Everglades works of the district permits that are issued. And they, as I understand, are issued to various groups within the EAA. And some of those permits are, let's say, have an expiration date or renewal. Is it the goal of this project is to really redo the research effort, but is it also to consider how those BMP implementation permits are issued, the Everglades Works of the District permits individually to the different corporations within the EAA? Kind of questioning of whether during that permit renewal process, do you implement better BMPs, and are the BMPs basically that are described in the manual, as I understand under the BMP manual, Florida Vegetable and Agronomic Crop Manual, that's where most of the BMPs for the EAA are described. But our concerns are pretty much with, how we implement not only the water quality BMPs and source control as outlined in the research effort, but also, how we outline the quantity of basin runoff that comes out of the EAA that's therefore having to be treated through the STAs and into the Everglades. That treatment process could be ameliorated, as we've written in a white paper and as described by University of South Florida paper back in 2018, that there's potential to hold more water within the EAA in the water table in order to not only store that water there, but also be able to help control subsidence. Subsidence being we're losing a lot of those muck soils through oxidation because of over drainage. And there's potential in a BMP to be able to have more water storage in there and not permit so much discharge into works of the district through this permit process. So I hope some of that can be addressed in this next increment of research. Thank you.
Okay, thank you, Mr. Perry. This is Gary Priest. We've received your comment and we'll respond accordingly. It's a multifaceted comment, so we'll have to provide a little additional feedback. Good. Thomas, can we go on to the next comment?
Yes, sir. All right, so we have a Mr. Gray.
Hi, folks. Can you hear me?
Yes, sir, we can hear you.
Okay, thank you. This is Paul Gray from Audubon, Florida. Mostly, I kind of had some clarifications that I was interested in. This is really great information. I'm glad you guys are looking at this because obviously trying to manage nutrients is a big thing. When you look at historical use of the property, and I'm thinking about nutrient control, are you able to make an annual nutrient budget? Do you know how much nutrient is applied to the farm versus how much is exported in products? Is that part of the data you are collecting?
Yes, hello. We have not done an annual budget. We don't track how much, the fertilizer, how much fertilizer is added is in the permits, but as researchers, we are looking at what is in the soil test because there's a lot of fates for the soil phosphorus, and it is important for us to see what is happening in the soil and the water. That's what we focus on. So in a lot of ways, we probably can an annual, but we don't really track how much phosphorus is added. So no annual budget at this point. Yeah.
Okay, yeah, thank you. Well, and that's kind of important when you look at the soil phosphorus absorption capacity, because if you have a net import every year, the receptors in the soil, the aluminum and iron and whatever, can get taken up. And then over time, the amount of phosphorus the soil will absorb will be less, and the amount of runoff you might have for the same application rate might be more. And so that would be a really important thing if we could get a better handle on that. So that's just a suggestion. And then the other thing is I noticed that there are no farms in the S8 basin, and it was characterized as Dania muck, and it's shallower and it has somewhat different characteristics than the basins you're working on. And I know funding's not unlimited. So I was just thinking that if you could get some farms in the S8 basin, of course, that's a lot of water that we want to send back to the Everglades, and we want it to be as clean as we can get it. It would be useful to have more information in that basin because it is kind of a different type of condition in the EAA. It's, the farms you're working on are not quite similar to that, or not real similar. And if we could get more data over there, that would really be useful. So we appreciate your work, and thank you very much for what you're doing.
Well, thank you. That's a good comment, and we'll take that definitely into consideration. Thank you for that comment. Very helpful.
Thanks.
All right, thank you for your public comment. Are there any other public comments before we transition to the next phase of the meeting? All right, so that is it for public comments. Thank you, everybody. And is there a hand raised? Oh, okay. All right. Okay, so we have Mr. McVicker.
Yes, thank you. I hope you can hear me. I did press the unmute button.
Yes, we can hear you.
I just didn't want this opportunity to go by without complimenting everybody who's been involved with this program for the last several decades. Nothing this big and this successful ever happens without a huge commitment by a whole lot of talented and dedicated people. And this program has been very lucky to have good leadership from the beginning, certainly great leadership with Samara in the last X number of years. And we don't get a chance very often to acknowledge what an amazing process this has been and what a great benefit it's been to the Everglades since 1996 when the rule was first put in place. So congratulations to everybody involved. Keep up the good work, and we certainly are impressed with what the results you've been able to obtain. Thank you.
Thank you very much for your comment. Much appreciated. Okay, one more last call for any other public comments. All right, so moving forward, the next steps in this process. So today, July 16th, 2025, the public workshop. This is also the beginning of the public comment period. So for the next 30 days, anybody can make public comment on this master research scope of work proposal. All comments and questions can be sent to South Florida Water Management District, care of Priest. His contact information is here, priest@sfwmd.gov. This public workshop will be posted to the channel. The district YouTube channel is SFWMD TV. And so anyone can review everything that was discussed here today. And if you have public comments, they can be sent to Gary Priest. July 23rd, 2025, a week from today, the draft permit will be posted to e-permitting for everyone to review. Again, that is on e-permitting. August 15th, that is the end of the 30-day comment period. So that is the last day for you to make your public comment to Gary Priest on the master research scope of work proposal. August 7th, 2025, the proposed permit will be posted to e-permitting. So any tweaks or adjustments or changes between now and then, that proposed permit will be posted, and no later than November 3rd, 2025, the last day for agency action. So the final district action on the permit application will be made by September 3rd, 2025. All right, and with that, this meeting is adjourned. Thank you all for your time and your presence.